be so obnoxious for the rest of ever, probably, but I'm still in shock. So here we are.
Okay. Let's look
I
at.
also was like, what? How the hell did you take that derivative? And I'm like, Jesse, you're doing limits. God damn.
So, sheesh indeed. Sheesh indeed.
Cosine of x.
Let's look at a couple of. Let's do a couple more like word problems, and then we'll have some work time. I'll try to keep us under 20 minutes here.
We do 25.
25.
Not quite team number.
Yeah, we can do 25. I was gonna look at.
That just looks a little scary to me.
I was gonna do 22 with you because it touches on.
Let's do the under derivative one.
First? Sure.
I don't
Okay.
care which one we do
So
first.
25.
So you guys might know the answer to this already since we've actually already discussed this briefly. So.
Oh yeah, I remember this.
So here's a function, x times e to the x. And so
What's the one that you just keep adding?
if you take the derivative, Jesse, I think you in here. The derivative of this is, you got a times b, so you go a prime times b plus b prime times a. Okay? That part by now should be fairly easy for you, hopefully. Okay? Because you gotta start focusing on, at a certain point, the mechanics have to become simple, fluent, so that you can then focus on applying mathematical reasoning to something that's a little bit more complicated. If you get hung up on the basics, you're gonna have a really hard time. So watch it happen. What we can say is, well, you gotta have this perspective of like, well, look, taking the derivative is the same thing as adding on one of these. Okay? Just for good measure, let's take the second derivative just to make sure like we're not confusing ourselves. Well, the second derivative would be this, e to the x, e's its own derivative, plus, what's the derivative of this term? Yeah, we just did it, right? We just did that question a second ago. So the derivative of this is e to the x plus x e to the x. And I can say, oh yeah, okay, those guys is 2e to the x. So then that kind of confirms it, that the first derivative has a single e to the x added on. The second derivative has 2e to the x's added on. Therefore, so then this is a pretty good argument. Just symbolically, a sentence wouldn't hurt. But then, therefore, logically, the 100th derivative, how many times would this have been added on? 100 of them. There you go. So, does every function have an obvious 100th derivative? Of course not. But society.
Wait,
We live in a society.
what would you say in a sentence like, because the derivative of x e to the x times e to the x is x times e to the x plus an e to the x.
Just say e to the x 40 times and it'll work.
I don't know. There's a million sentences. Like I might phrase it as like, we can see that each subsequent derivative adds an e to the x onto the function, and so taking the 100th derivative would add e to the x on 100 times. Therefore,
Yeah.
and just the beauty of math is that this, I would argue that this is a clear enough line of reasoning
Yeah.
that it supports your answer pretty well if you show the first and the second derivative. A really good mathematical statement that would be very solid here would be something like f prime of x is equal to e to the x plus f of x, because that shows kind of like a recursive sort of relationship there. Because that it logically follows from that this is true. So, no need to go back to 22. Are we fine with that?
Sure.
Well, wait, what is the? Even.
She was just talking about same thing. It's where's it increasing, where's it decreasing, where's it concave up, where's it concave down. I don't, we can go over it. It's fine. And Aiden votes yes,
It's up to you. It's a thinky winky.
and Aiden's my bro, so that's what we're gonna do. Huh?
Josephus.
Lord,
Abraham Lincoln.
What?
my sticker. Where did it came
Abraham
off?
Lincoln.
Oh, that's lit.
But I think that was because my mom washed it with bleach. So I think that's on my mom. But anyways, it's most of it's
My
still
mom.
there, so yay. I love this sticker. Look, Laura got it for me. It's a sustainable sticker. Biodegradable. Isn't that wild? Amazing.
Sheesh. That feel when you're in the future and all the boys have sustainable stickers, and it's like sheesh. Am I right, guys?
Yeah.
Yeah.
I've never even seen a boy. Just kidding.
I'm not.
I wonder if Griffin knows the sheesh.
One more month.
Yeah,
I
when
was
you're on
100%
TikTok.
He's not Griffin. Griffin, make sure you comment.
He sends me a lot.
I
Subscribe to TikTok stuff.
He sends me like 5 a day.
I mean, it's fine. I'm like, thank you. It just, I would take.
Griffin, you're sending all these TikToks and you never emailed me one? It's a little hurtful,
Come on,
bro,
Griff.
honestly. Sheesh. And what's the opposite of sheesh? That's what I was trying to say to him, because that feel when you get left unread by not having been emailed TikTok links.
Bro.
You guys know that feel? You get left in the digital dust. Okay. This guy. One of the fun parts of this question is the thinky winkies that you don't even use the quackmalus for, because if this is what the graph of the log of x looks like, this is the graph of log of x. What would happen if you multiplied that graph by itself? If at every x value, the new y value is the old y value multiplied by itself. So,
It gets weird.
well, there's some interesting stuff going on. For one, the domain is the same, doesn't change the domain. Yeah, first of all, this thing now is not going to have any negative y values, because all these negative y values get squared when you square the function. So for one, it seems to be fairly straightforward that it's going to have a positive asymptote, and then it's going to still hit 0 at the same spot. Where does this guy hit 0? At 1. So it's still going to hit 1. Now, an interesting calculus question is it going to be pointy there?
That is the question.
Because if you absolute valued this thing, then it would be pointy there. But maybe it works out with the squaring that it comes in and just kind of bounces off like a round boy, right? And then it seems like, well, I don't know. This is where the curvature is not really obvious. Is it going to curve up like this, or is it going to still have that kind of like shape like that? I'm not really sure, right? Does that make sense? Because you know it's another curve that looks kind of like this? The square root curve. And if you square the square root curve, it turns linear. Right?
Which is lit.
So this one, I don't know, this guy I think is flatter than the square root curve. So I think he's gonna do something like this. This is my prediction, but I'm not sure. But you get the general idea, right? Do a rough idea that it's gonna look like this. Now this could have come last too. We could have just not done this and just done all the calculation and used our calculations to figure this out, right? It's making sense. So, first derivative. How do I have to think about this dude to take the derivative of him?
U to the square.
Yeah, I gotta think of this as being like a
U to
u
square.
squared, which I know u squared will turn into
2u.
2u times u prime. So 2u times u prime, right? Makes sense? Which I know I'm taking the second derivative because the question is asking about the concavity, so I gotta take the second derivative for that. So I'm probably gonna write this as maybe 2 over x times the log of x. That to me seems like maybe the nicest way to write it. So I have an a and a b for product rule.
Can you do it to,
You
well,
can
of course you can.
You can keep it like this. I don't know. Maybe
you
this isn't
You
any
can also
better.
do closure.
Oh yeah, good point.
I mean,
that'll
that's how I
work.
would do it.
You do quotient rule.
Okay.
Is that what-
I'll do it and you do product rule.
Let's do quotient rule. That sounds lit.
Okay. I'm sorry. I'll do
Right,
it.
that feel when you and the
Not
boys
you.
do the quotient rule when you could have done the product rule. Sheesh, right? Yeah.
It's like me when I do the quadratic formula when you didn't need to.
Yeah.
No, that's just dumb.
Well,
Okay, yeah,
but
that's
I
fine
don't wanna
too.
complete the square. Completing the square is lame.
Okay.
It's all lame.
That is offensive speech. Completing the square is amazing. It's great. Okay. We live in a society. So now we gotta use the quotient rule. So we're doing A over B turns into A prime B minus B prime A all over B squared, okay? So A prime is,
No.
nope, this is my A.
Yeah.
Yeah.
Let's list it out, let's list it out.
Roll for it.
A is 2 log x, no, A prime is just 2 over x.
It's just over X, yeah.
2 is just a number, so the derivative of log of x is 1 over x. The derivative of 2 times log of x is just 2 times 1 over x, 2 over x.
It's pure.
This,
We
okay?
gone to the big fat
Yeah.
world.
If this had been like an x or something, then yeah, we would have to use the product rule, but it's just a 2. So 2, derivative's 2 times bigger than the derivative of log of x. My b is x, so b prime is 1. What beans there?
Coolio
You
beans.
betcha.
Okay, so now I can use the quotient rule, so I can go a prime times b minus b prime times a all over b squared.
No? It's not A prime.
Did I mess it up?
A prime times.
A prime b minus
A prime is
A prime. 2
uh,
over X is A prime.
little Mal, just testing you, obviously.
two.
Good thing we wrote it out. A prime times b minus b prime times a. There you go. Isn't that nice?
You can say that.
Ave has other words for that.
I
What?
always have other words.
Not nice?
They're not nice, yeah.
So there's 2 things we got to look at now. Is I gotta maybe it was jumping the gun going straight to this because we didn't even finish looking at the derivative, right? So if I make my f prime number line, oops, doesn't need to be a line.
Doesn't.
It can be array
Ah.
because you can't plug negatives into that thing to begin with. So
No,
Yeah.
sir.
okay,
Yeah, Jay.
focusing in on this.
What's up with that?
What x value, there's no algebra required here, it's just a basic math fact. What x value makes this equal to 0?
1. 0. I was right?
Well, 0 is, you can't plug 0 into this.
And 1 because.
1, because
Right.
the log of 1 is 0.
Yay, yeah.
Okay?
For
The log of
once,
1 is
or
0.
twice.
So,
Thanks, Jesse. For twice.
and that's the only number, right? That's the only number that makes this 0 or undefined, right?
Gonna have to turn
Yes.
them all back.
The only positive number.
Yes,
Obviously,
correct.
0 makes it
Correct.
undefined, but 1's the only other number. So 1's our only critical number, 0 and 1. Now, if you plug in a number that's between 0 and 1 into this, what kind of number comes out?
A very large.
Yeah, it's negative, yeah, right? I mean, the graph tells you that. Any number you plug into this between 0 and 1 will give you a negative output. So if you plug a 0.5 in here, it's gonna be negative. Does that agree with our hypothesis over here? The conjecture?
Yep.
Yeah, decreasing function. And then from 1 to infinity, if x is bigger than 1, well, then log is positive, so that would be a positive number. Telling us that f is increasing. So we're already feeling pretty good that this graph was, at least in terms of its decreasing then increasing property, it's cool. Beans. It's hype. Yeah. All right. Let's look at the second derivative. This one's a little bit more confusing.
Do we
Questions?
simplified that or no?
This? We could, yeah. Might make our life easier. So
Yeah.
this is
2.
Yeah,
2
it's-
minus
it'll do.
2 log x all over x squared. And
Really?
the question is, can this guy, well, firstly, 0 again is causing problems for us, right? So what's the x value that would make this equal 0? 1. Let's, okay, I'm glad you threw out 1. 1 is a great first thing to look at, okay? Let's just try it. Plug in 1. What does this become if you plug in 1? 0. 2 minus 0 is 2. Okay, I guess
Yeah.
Dude, but I mean, really, when you think about this, the numbers you want to look at are 1 and e. And then maybe it's going to be a 1 over e or 1 over e squared or something, but it's not going to be like some crazy complicated answer. The answer is what? What e?
E.
Cool beans? Make sense?
Yes, it does.
If you want to do algebra, it looks like this. You set this equal to 0, multiply both sides by x, so you have 2 minus 2 log of x equals 0. And then you solve, you have log of x equals 1, so e to the 1 power equals x, so x has to be e, if you're a big algebra fan. So, okay, if we plug in a number between 0 and e, this is also another good fact to know about this function. This point right here is e1, right? When you plug in e, the log function, you get 1. So if you plug in any number that's lower than e, less than e, your y value is going to be less than 1, right? So if your x value is less than e, then this number is less than 1, and so that makes this a positive number. What?
Nothing. I'm just funny.
Oh my god.
I have a feeling
I'm
to
so-
Jesse's Star
I'm
Wars
so
humor.
sorry. That was hilarious. Oh my gosh.
Okay.
I am delirious, you guys. I've been delirious since Tuesday night at 5 o'clock.
Nope.
No, PM.
PM.
Yes, Tuesday night at 5 a.m.
Anyway,
I wouldn't put it past
If
you.
x is bigger than e, for example, a number like e squared or e cubed, well, then this number here would be bigger than 2, thus making it negative. Okay, so we go concave up, concave down. By the way,
That works.
was there a pointee?
No.
Who do I look at to know if there was a pointee?
think it's cancel out, right?
The first derivative.
Right here.
Onesie.
Because if there was going to be a pointee, it was going to be at 1. Now, a pointee is we only know it's going to be a pointee if this gave us like an undefined derivative. But if you plug in 1, it's not undefined, it's just 0. That tells me that there's a nice smooth Humpty Dumpty at 1. And then, so the last thing, guys, I've seen a lot of students have trouble going from this to the graph. So my recommendation typically is to, if you're having trouble with that, is to combine them into a single descriptive number line where you go, what are all my numbers? 0, 1, and e, and then just combine your information and turn them into noodles. Macaroni type of noodles, not like any other kind. So you go decrease. So between 0 and 1, we were decreasing in concave up. So decreasing concave up. Between 1 and e, we are increasing concave up. And between e to infinity, we are increasing concave down. And then we know that each one of those describes a noodle. A decreasing concave up looks like this. An increasing concave up looks like this. And an increasing concave down looks like this. And if you piece all those noodles together, you get this
Like
shape.
a necklace.
Does that make sense? Piece the noodles together?
What? You know, the noodle
No?
necklace.
Yes?
Macaroni necklaces.
Okay, so then that,
Jason knows what I'm talking
of course, that doesn't get you all the details, but that combined with your knowledge of some math facts and graphs
about.
will get you. What? Zoom out.
I'm sorry.
So basically, Jay, well, it's probably nice to have me in your class because I really love math, but it also probably sucks for every other reason.
No, it's lit. It's for all reasons. It's lit for all reasons.
Okay.
Jacob.
Oh my gosh, Jacob, when I'm gone, I listen to I watch the recordings, but I always watch them on 2x speed because my brain can't watch videos that like, well, I mean it can, but I don't know. I just prefer to watch it fast. And so like, there's this one. At one point, Ave's laugh was like, I was like, oh my god.
On 2x speed?
Yeah, it's like,
Okay.
I don't want to hear that. That sounds awful.
So guys, there's I'll save the implicit differentiation for tomorrow. So just take the rest of class. Got like 20 something minutes. Knock out the rest of these. It's most important. What's the min max? What's the min? What's the max? What's the concave up? What's the concave down? Just taking derivatives.